For this lesson, we're going to be continuing on with our combinations. And we're going to be working through a few different problems here so that we can practice reading through them, figuring out how to approach the question, how to figure out if it's a permutation question, a combination question, and just how we should start calculating all of the number of ways because it can get a little confusing which method we should be using. So for this first question, a new type of fast food restaurant has just opened near Aurora High, and it's called Baskin Burger. They offer 31 flavors of ice cream and 8 different toppings for their burgers, so things like ketchup, mustard, onions, pickles, that kind of stuff. Their lunch special consists of a burger, a side dish of fries or onion rings, and a milkshake, which is made using 3 scoops of ice cream. So the first question asks us, how many lunch specials have 5 different toppings on the burger and 3 different scoops of ice cream in the shake? So our ice cream that's put in, there's no doubles. All 3 scoops that are put in the milkshake are all different. And looking out for pieces like that are really important when we're approaching these questions. So let's start by writing out what our lunch special consists of. So my lunch special consists of a burger and a side and the ice cream that goes into our shake. And the reason I'm focusing on the ice cream is because we have all these different flavors going into the shake, that's really going to impact all of our different options for this lunch special. So first, our burger. So our burger has 8 possible toppings, and in this example, we're looking for lunch specials that have 5 toppings. Now I want to start thinking, does order matter for these toppings? And in this case, it doesn't. It doesn't matter if I have ketchup, mustard, or onions, or mustard, onions, and ketchup. Those combinations would be the exact same thing. So this is a combinations question. So there are 8 possible toppings, and I'm going to choose 5 of them. Then for our lunch special, we have a burger and a side. So that word and here, remember from lesson 1, is telling us to multiply. Next, let's look at the side. So for our side, we have fries or onion rings. Similar to our burger, the order doesn't matter here because we're either going to have fries, which is just fries, or onion rings, which is just onion rings. So there's no way that the order can matter for the choice of our side. So we had 2 options, and we're picking one of them. Now we have our burger and our side, and so we multiply again our ice cream for our shake. Now in this case, we're getting 3 different scoops of ice cream. So we have 31, choose, 3 flavors. And it's a combination question because the order doesn't matter here. It doesn't matter which scoop is on the bottom, middle, top. That doesn't matter. All that matters is I'm picking 3 flavors out of the 31. So on your calculator, there should be a combinations button, so one that says NCR. If you don't have that button or you don't know how to find it, you can calculate it by hand and then ask me how to find it via email and I can help you that way. So if you have that button or you calculate it by hand, you should get 503,440 different lunch specials where you have 5 different toppings on the burger and 3 different scoops. So for example B, we're going to change it up a bit and we're going to reduce some of the restrictions, which typically makes the question a little bit more challenging. So for example B, we want to figure out how many different lunch specials are there in total. So no restrictions, but in total. The only thing we are assuming though is that customers can't order double toppings, just so that it doesn't get too out of control and we don't make the number of options just a crazy big number that won't fit in your calculator. So we're looking for the total with no restrictions. So again, let's write out the things that come in our lunch special. So first, we have our burger, and we'll have a side, and we'll look at that ice cream again. And again, I'm writing ice cream instead of the shake because the flavors do matter, because depending on the flavors, it would be a different shake. Now for our burger, we can basically have any of the toppings, yes or no. So that is an example of our binary combinations. Do you want ketchup? Yes or no. Do you want mustard? Yes or no. Do you want pickles? Yes or no. In addition, we can also have a burger that's plain, right? So we don't need to have that -1 because we can have a plain burger. So we have 2 to the power of 8 because it's our binary rule. Again, ketchup, yes or no, mustard, yes or no, etc. So if I put that in my calculator, I'll get 256. Now for our lunch special, we have a burger and a side. So because I'm saying the word and, it's telling me that I multiply. Now let's look at our side. Our side in this question is approached the exact same way as it was in the last question. The order doesn't matter because we're either getting fries or either getting onion rings. So it's a combination question, 2 options. Let's just choose one of them. So we have our burger and our side and our ice cream. So because we're using and, we multiply. Now the ice cream gets a little tougher because there are different options for the number of flavors. I'm going to put 3 scoops into this milkshake, but there are some options for how I pick those 3 scoops. I could pick 1 flavor, or I could pick 2 flavors, or I could pick 3 different flavors. So remember, because we're saying or this time, it means we're going to add these. So let's start by looking at the 1 flavor. So if I just decide to get all vanilla, all chocolate, something like that. So 1 flavor is going to be 31 ways. So I could either get chocolate, vanilla, strawberry, etc., 31 different ways. Then I could get 1 flavor, or, so I add 2 flavors. And this one is probably the trickiest one. So for 2 flavors, the order doesn't matter because they're all going to go into this milkshake. So it doesn't matter if it's chocolate vanilla chocolate or chocolate vanilla chocolate. Those 2 chocolates switching out doesn't matter. It also doesn't matter if we have chocolate vanilla strawberry or strawberry vanilla chocolate. That order doesn't matter, so it's a combinations question. So I have 31 options, and I'm going to choose 2 of them. Now there is something extra that we do have to take into account here though, is when I choose 2, there are a couple options that we do need to account for that this won't. So we will need to multiply this by 2. And the reason we have to do that is because we can have something like chocolate, chocolate, vanilla, or chocolate, vanilla, vanilla. And those 2 things are still different, but we need to multiply this by 2 just to make sure that we account for all of those options and all of those situations. So when I put that in my calculator, I will get 930. Finally, I could have 1 flavor or 2 flavors or 3 flavors. So for this one, I have 31 options and I'm going to choose 3 of them. Now, because all my options are different, I don't need to worry about any of these chocolate, chocolate, vanilla or chocolate, vanilla, vanilla situations. I can just do 31, choose 3, which is going to give me 4,495. So now let's total up our ice cream. And because I can only get one flavor or two flavors or three flavors, it means that those events are mutually exclusive and that I add them. So I will have 31 plus 930 plus 4,495. And when I put that all in my calculator, I will get 5,456 options for my ice cream. So now I figured out all my options for the burger, the side, and the ice cream. So now I can get my total number of lunch specials. Now remember, I have a burger and a side and the ice cream, so I multiply them. So I have 256 multiplied by 2 choose 1 is just 2, multiplied by our 5,456, which gives us 2,793,472 options. So let's try another example that's a little bit different. So the next one here, John is at HMV and he's actually buying his music in order to support his favorite bands. There are 7 CDs that he really likes. How many different purchases are possible if he wants to come out of the store with at least one CD? Now, the important piece to note here is that he is going to buy at least one CD. So there's no situation where he comes out empty-handed. Now, if I think about my options for purchases, and I'm looking at CD number 1, I could either purchase CD number 1 or leave it on the shelf. Same with CD number 2. I could either purchase it or leave it on the shelf. So this is an example of our binary choice. I can pick CD1 or I can leave it. And I can do that for all 7 of my CDs. So I have 2 to the n minus 1. And the reason I'm subtracting 1 here is that he can't come out of the store empty-handed. So we have 7 CDs, so we'll have 2 to the 7 minus 1. And using BEDMAS, I always do my exponents first. So I have 128 minus 1, which is 127. Now there are a couple other ways that you can think about approaching this. So we can also use combinations. So if I think about it, one option could be I could look at my 7 CDs and just choose one of them. Or, so I could be looking at my 7 CDs and pick 2 of them. Or I could be looking and pick 3 of them, or pick 4 of them, or pick 5 of them, or pick 6 of them, or pick 7 of them. And if I put all of that in my calculator, I will also get 127. Doing it this way does help you to see how these two are connected. So if I want to use combinations, I absolutely could, or I could use the fact that it's a binary choice, just yes or no, and use the formula on the left. So one more example. So for this last one, Jane has 4 pennies, 3 nickels, 7 quarters, and 9 toonies in her piggy bank. Using the coins that are in her piggy bank, how many different sums of money can she make? So now I have different groups of objects that are alike. So I have a pile of pennies, pile of nickels, quarters, toonies. So this is very similar to our marble question from yesterday. So let's start by identifying our objects. So I'm going to let P represent my number of pennies. Then I'm going to let Q represent the number of nickels. Then we'll let R represent our number of quarters. And finally, we'll let S represent our number of toonies. So now if I think of my formula for when I have situations like this, where I have a pile of pennies, a pile of toonies, or piles of the same objects, I'm going to take P plus 1, multiply that by Q plus 1, multiply that by R plus 1, multiply that by S plus 1, and then I subtract 1 from all of that. And I subtract 1 because I do want a sum of money and I don't want the 0 option. So I'm going to subtract that out. I'm going to get rid of that by subtracting 1. So now let's fill in our values. So P is the number of pennies, Q is the number of nickels, R is the number of quarters, and S is the number of toonies. So now I have 5 times 4 times 8 times 10 minus 1. And when you put that in your calculator, you'll get 1,599 different sums of money that she can get.